Jai Hind everyone. Today we are going to learn about chapter number 4, structure of atom. These are the objectives of chapter. We will learn about the model of an atom. First model is Thomson's atomic model. Second model is Rutherford model of an atom. Third one is Bohr's model. And at the last we will learn about the electrons in different orbits and atomic number, mass number, isotopes and isobars. Now, what is atom? Atom is the indivisible substance. The meaning of atom is indivisible means the substance which cannot be divided further. This is Greek word which means indivisible, and Greeks concluded that matter could not be broken down into particles too small to be seen. These particles were called atom, and atom consists electrons, protons and neutrons. Now both the protons and neutrons reside in the nucleus. Protons have a positive charge and neutrons have no charge, and they are neutral. Electrons reside in orbits around the nucleus. They have negative charge. It is the number of protons that determine the atomic number. For example, hydrogen's atomic number is 1. It means the number of protons is 1 in hydrogen. So, always the number of proton decide the number of atom. The same element may contain varying number of neutrons. These forms of an element are called isotopes. So now we are going to learn about the term isotope. The chemical properties of isotopes are the same always, and the physical properties of some isotopes may be different. Some isotopes are radioactive. Meaning of radioactive means the radiate energy as they decay to more stable form. And another example is hydrogen with atomic number of 1 can have 1, 2 or 3 number of neutrons. Now, first model of structure of atom is proposed by J.J. Thomson, that is known as Thomson's model of an atom. J.J. Thomson proposed that an atom was a solid sphere of positively charged material and the negatively charged particle electrons were embedded in it like the seeds in a watermelon. The red edible part of the watermelon is compared with the positive charge and the seeds are compared with electrons. The atom as a whole is electrically neutral since the negative and positive charges are equal in magnitude always. Although Thomson's model explained that atoms are electrically neutral, now second model proposed by Rutherford, and this is known as Rutherford scattering experiment. E. Rutherford carried out experiment in which charged particles were shot through thin foil of metals like platinum and gold. The charged particles used were alpha particles having 4U mass. A thin foil of metal was expected to contain a few layers of atom, and the motion of charged particle incident on the foil was expected to get influenced in different ways depending upon distribution of positive and negative charges. Now, on the basis of Thomson's model of atom, it was speculated that on passing through the metal foil, the charged particles would get deflected through a small angle. Most of the space inside the atom is hollow or empty, which allows the particles to pass straight movement. There is some positive center present in atom which deflect or repel the alpha particle. This positive charged heavy body in the center is known as the nucleus. The total volume occupied by a nucleus is very small as compared to the total volume of the atom, as very particles are repelled or deflected by a wider angle. So this is the Rutherford's scattering experiment. It has some drawbacks that we will learn later. Based on his experiment, Rutherford put forward the nuclear model of an atom. According to this model, an atom consists of a positively charged center, the nucleus. At a considerable distance from the nucleus, the electrons were orbiting in manner much like the way the planet orbit the sun. This model is also called a planetary model of atom. The nucleus of electrons in orbit is equal to the number of positive charges in the nucleus. The volume of the nucleus is negligibly small as compared to the volume of the atom. For example, if we consider the radius of atom is equal to 1 kilometer, then the size of the nucleus will be equal to a cricket ball present in the core center of the atom. Hence, most of the space in the atom is empty. This is the conclusion of Rutherford's experiment. Now we will see some drawbacks of Rutherford nuclear atom model. Rutherford's model has the drawback that as the nucleus and electrons are held together by electrostatic forces of attraction, it would lead to the fusion of the nucleus with electrons. This does not happen in the atom. For this, Rutherford gave the explanation that electrons revolve around the nucleus in a spiral path. This too is not satisfactory because is following a spiral path, energy is lost by the electron and ultimately they will fall into the nucleus. But atoms are stable. So this is the drawback of Rutherford model. Now the another scientist came, Bohr, and he proposed another model, that is Niels Bohr model. He proposed modified model of atomic structure in order to overcome the difficulties of Rutherford's model, which is the first step towards the modern atomic theory. These are some postulates. Electrons revolve around the nucleus in a limited number of orbits called orbits. Each of these fixed orbit has a definite energy, hence they are also known as energy labels or energy shells. These shells are labeled by K, L, M and N. The energy of an electron remains constant so long as it stays in a given orbit. Electrons present in different orbits have different energies. When an electron jumps from a lower energy label to higher one, some energy is absorbed. When energy jumps from a higher energy label to lower energy label, some energy is emitted. The amount of energy absorbed or emitted is given by the differences of energy associated with this structure. Energy absorbed or emitted, this is the formula delta E is equals to E2 minus E1 and that is equals to h mu, where h is a Planck constant and the frequency of radiation absorbed or emitted is represented by the another sign. Now electron distribution in various shells we will learn. Bohr and Bury suggested the distribution of electrons into different orbits of an atom. The number of electrons present in a shell is given by the formula 2n square, where n is the number of orbit. The maximum number of electrons that can be accommodated in the outermost orbit is 8 and the penultimate shells cannot have more than 18 electrons. These are the rules for distribution. Now the another topic is valency. Valency is the combining capacity of an element. For example, the capacity of an atom to chemically unite with a definite number of atoms of other element. The combining capacity of the atom of the element that is explained is an attempt to attain a fully filled or octet configuration of outermost shell. Boron has a valency of 3 and carbon has a valency of 4. Since the outermost shell has 3 and 4 electrons respectively, since fluorine has 7 electrons in the outermost orbit, it loses 1 electron to attain the octet configuration. So, the valency of fluorine is 1. I hope it is clear to you. Now, what is atomic number? The atomic number of an element is the number of protons present in the nucleus of an atom. Since an atom is electrically neutral, the number of protons and electrons is equal. Therefore, atomic number is also the number of electrons present in an atom. For example, carbon's atomic number is 12. Carbon's atomic number is 6. It means it possesses 6 electron and 6 proton. The mass number of an element is the sum of the number of protons and neutrons. For example, Z, we will consider an element's mass number, and it is represented by Z. The number of proton in the atom is Z, the number of electron in the atom is Z, the number of neutron in the atom is also Z. Structure of hydrogen and oxygen atom is another topic. Hydrogen atom, number of proton P is equals to Z is equals to 1. Hydrogen consists 1 electron only. Number of electron, that is represented by E, and number of neutron, this is the number of neutron in hydrogen is 0. Therefore, the nucleus of hydrogen consists of only a proton. There is 1 electron in the first orbit. Now oxygen atom, atomic number is 8, mass number is 16, and number of proton is also 8, that we have already seen. Number of electron is 8. So its number of neutron we can find out easily with the help of this formula. So the mass number of oxygen is 16, atomic number is 8, number of electrons and protons are always equal. Now another term is isotopes. Dalton in his atomic theory stated the atoms of the same element are identical in all respect of size, shape and structure. Scientists believed in this hypothesis of Dalton, but later it was disproved an element may have more than one kind of atom. See the example. They may have same number of electrons and protons, but they may differ from each other with respect to number of neutrons. For example, hydrogen. Hydrogen possesses 1 electron. Its mass number is 1 and it possesses different number of neutrons. Atom of the same element having same atomic number but different mass number. In other words, isotopes differ from each other with respect to number of neutrons. Almost all elements have isotopes. Isotopes of hydrogen. There are 3 isotopes of hydrogen. First is protium, second is deuterium, third is tritium. Protium atomic number 1 but number of neutron 1, and deuterium neutrons 2, tritium neutrons are 3. Atoms of different elements with a different atomic number but with the same mass number are called isobars. For example, calcium and argon. Both have different number of electrons and have different atomic number, but they have same mass number, that is 40, and so they are said to be isobars. So isobars and isotopes both are different. So I can I hope it is everything is clear to you. So can I explain you about some facts? In 1911, Ernest Rutherford discovered that the majority of the mass of the atom is located in the nucleus. Most of the mass of atom is located in the nucleus, which also contains the protons and neutrons. Protons are 1836 times as massive as electrons. Their opposite charges are exactly equal in magnitude. Electrons cannot make a smaller orbit around the nucleus because as a quantified by Heisenberg uncertainty principle. This Heisenberg uncertainty principle, you will learn about this principle in higher classes. So what is the summary of this chapter? Let me summarize this. J.J. Thomson proposed that an atom was solid sphere of positively charged material and the negatively charged material electrons were embedded in it like the seeds in a watermelon. Second, Rutherford's alpha scattering experiment lead to the discovery of the atomic nucleus. Rutherford proposed that electrons were orbiting in a manner in the same way as the planets are orbiting in the sun. Hence, the model is also called as planetary model of atom. Bohr proposed that electrons are distributed in different shells with various energy levels. The atomic number of an element is the number of protons present in the nucleus of an atom. Atom of the same element, rather elements having same atomic number but different mass number, are called isotopes, and atoms of different element with different atomic number but with the same mass number are called isobars. Thank you.